In this exercise, we're going to look at how we can use our graphic calculator to create a scatter plot, and then from that scatter plot to put a line of best fit. Alright, to begin with, we need to have some data inputted. So go to your home page and go to spreadsheet. Now I've already put in some data from some information I made up. What the question would be looking here at would be how many students enjoy apples or oranges, or in this fact how many apples or oranges have students eaten over the last period of time. So let's say a month. So first student has eaten 5 apples and 4 oranges in the last month. Now in order to enter this data we need to have a heading. So it could either be X and Y, you could use A and O. I've put the whole word in, apples and oranges. That goes in the line at the very top. The next line we leave blank, and then we start to put our data in. So line 1, put our first set of data for person number 2, 7 and 6, person number 3, 6 and 5, person number 4, 2 and 3, and I've entered enough data down for 8 people. So essentially what the data is looking at is to see if there's a correlation between how many apples and how many oranges a student may eat in a month. So the data has been entered. Now what we want to do is to plot that. So we'll go back to our main menu just so we get it onto a new page, and we'll choose the graph menu. So down here, the purple one, graph. Now data's already been put on. Now it's relatively random. Right, so we need to give the axes some information as to what information is to be plotted. So down the bottom where it says click to add a variable, we're going to add a variable and we're going to add apples. And on the left hand side, we scroll the mouse across the left hand side, it asks us to click another variable, and this time I'm going to add the variable oranges. So we are plotting apples and oranges to try and compare them. Now you notice that the dots are now placed as we would in a scatter plot. If I have a look at those points, I can see that there seems to be a fairly strong correlation. Right, the dots seem to be appearing to go in a relatively straight line. I can also say that the correlation looks to be positive because it is going up. So strong correlation, positive correlation. Now if I want to make a line of best fit, I'd probably get my ruler, and somewhere along here I'd get the ruler and I'd start going up in a straight line. Well, we're going to take that one step further, and we're going to get the computer to calculate the line of best fit and to give us a formula for it. So while we're on this page, we then go to the menu button on the calculator. Now we don't want to change the plot type. We're quite happy with the plot we've got. We don't want to change the properties. What we want to do is we want to analyze. So as soon as I go to analyze, you can see down the bottom there it has a word called regression. Now the line of regression is what we've been using, the line of best fit. So we're going to use the first one up the top here, show linear. This is our mx plus c rule, even though they're using the letter B. So that's our typical linear rule. And there we go, we get the line of best fit. Now in this case, the rule that best fits the information we put into the spreadsheet is y equals 0. And I'll round it off to 6. 0.6x plus 1.4. So all you need to do, the information just needs to be rounded off to 1 decimal place. So the gradient would be 0.6 and the y-intercept would be 1.4. So you can see just here, this is the y-intercept just here, that would be about 1.4, and the steepness of that line would be approximately 0.6. So there's a pretty strong correlation. If I had to write that rule down, you'd write it down as y equals 0.6 of x plus 1.4. Now you need to try some of the exercises in the book to see if you can come up with the rule for the line of regression. Thank you.